Welcome to the BioMarine Live TV. My name is Guy Viel, the Executive Director of the Marine Biotech Research Center, Quebec, Canada. Welcome to this session. This session is with a subject thematic, extracting value from marine algae. For us, a lot of signification since the beginning of the convention around the cocktails and during the different activities. We hear around all about macroalgae and microalgae. Let me introduce the subject. The subject will be on extracting value of marine algae and specifically on microalgae, because our members of the panel this afternoon are involved particularly in the microalgae innovation. Let me introduce you. At my right, Kevin Okamoto, CEO of Gentry Bio. It's an Ohio company in USA. From Canada, Nathalie Bourdeau, Innofibre, researchers, and a company located in Quebec. And from Scotland, Douglas McKenzie, CEO of Sanctella. Welcome to all. The session will have three principal subjects. The first one will be on the presentation of each organization and expertise of each person in this organization, the member of the panel. The second question will be exactly on what do we mean with extraction of high value of microalgae based on particular original strategy or rationale of each organization with this thematic. And the last question will be for each panelist about the challenge and near future development in this thematic. So I will begin with Kelvin and follow with Douglas and after with Nathalie. Introduce you and your organization, including your expertise, brief description of activities of each of your organization in the field of macroalgae exploration, meaning research and innovation, production and commercialization. So, Kelvin.
Hello. Thank you for coming and listening to us. My name is Kelvin Okamoto. I'm the founder and CEO of Gentry Bio. Gentry Bio is a startup company for licensing, validating, developing, and commercializing technology for bio-based chemicals and bioplastics. Our initial effort is around the extraction technologies for microalgae. And improving the technology that exists today for most companies and trying to extract more value from more of the chemicals and cell contents in microalgae.
Okay, thank you. Douglas.
Good afternoon. Sanctella is my second company. I founded it in 2009. Actually, my background is a zoologist, so I have very little knowledge of algae, really. But it did strike me as a good place to make money within the marine biotech sector. And Sanctella's objective is basically to provide systems that will make it much more cost effective to produce algae, regardless where we're actually trying to do that. We're based in Scotland, up on the west coast near Oban. And I'll be talking a little bit later about our sort of approach to localized production of algae in rural and remote areas.
Thank you. And Nathalie?
Hello, my name is Nathalie Bourdeau. I'm a research scientist specialized in microalgae production at Innofibre. Innofibre is a college center for technological transfer, a non-profit research institution. We are located on the University of Quebec in Trois-Rivières campus, and we work very closely with the University Lab. Trois-Rivières is a medium-sized city in Quebec, in Canada. Our research center works on industrial applied research. We have a $80 million pulp and paper pilot plant, which is now considered as a major mechanical, thermal, and chemical biomass processing plant in Quebec. We carry out projects with more than 100 industrial partners in different sectors as pulp and paper, cellulose specialty products, bioactive paper, and also biomass pretreatment and conversion into bioproducts and biofuel. We can also have access to a Plenty Grants program to realize projects in a partnership with industry. Since 5 years, we have been conducting for about $2 million of research projects on microalgae production with 4 major industrial projects. Innofibre is also a member of a college center for technological transfer network called TransTech, in which we have a lot of collaborators with who can share knowledge and fulfill expertise for some needs in some specific project. And the synergy between technical college, university, and industry accelerate the research and facilitate the technology transfer to the company. And at Innofibre, we have a multi-sectorial approach, which consists mostly by using pulp and paper technology to solve problems or to improve process development in other sectors as algae production.
Thank you, Nathalie. So the question about extraction high value on microalgae mean acting for all of us, lower cost, perhaps high productivity, perhaps profitability, making money, or production and technology benefits for all. Each of your organizations seems to have your own specific and original strategy to obtain these objectives. Could you explain what is your strategy specifically, and if possible, the rationale behind this strategy? I will begin with Douglas.
Okay. When I came into forming the company, I had a good look at, well, where are the problems within microalgae production at the moment, and the answer was pretty simple. It's just too expensive. So our company was set up basically to look at, well, where's the cost coming from, and then look to see how we can extract those costs to make everything much more cost effective. We've got a number of strategies that we're following, but I want to tell you about a project that we're hoping to get going soon, where what we're looking at is there are many different ways which we can make microalgae more cost effective in production, but one of those is basically to reduce the feedstock costs. And what we've been looking at are what we call sweet spots, basically areas where you'll find all of the feedstocks that you need for growing algae locally available, either free or very inexpensive. Now, one of the features of that is that you're unlikely to find all of the feedstocks locally available if you're doing very large-scale production. So we were actually quite interested in identifying areas where you can have scales of production that are appropriate to the amounts of feedstocks that you have. And we've been using Scotland as a model. We're based there. And as most of you know, certainly if you've been to Scotland, we don't have an awful lot of sunlight to play with, certainly over the winter months. So we were immediately looking at using artificial light, and that pushes you down to immediately looking at high-value compounds as well. And there's a lot of interest at the moment, not just within Scotland and the UK, but in the use of the circular economy. So what we've been looking at are what sort of resources are available, and what we have in Scotland is a lot of distilleries. We make a lot of whiskey. Some of these distilleries are in very remote and rural areas, and it's actually really quite difficult for them to deal with getting their co-products dealt with. These are things like the pot ale, which is the material that's left after the distillation. But they also produce CO2, so you've got nutrients, you've got CO2. Now, the other thing that we have a huge potential for in Scotland is renewable energy. But actually on the West Coast, it's very difficult to deploy those resources because of grid constraints. So what we're looking at is actually using algae as a new industry for, particularly on the West Coast of Scotland, on our islands, to produce very high value compounds that can support local industries and the communities based there. So we're exploring the economics of that. Our job as Xanthella is really to produce the kit that will allow these areas to produce high-value compounds which will be competitive with ones that are being made elsewhere because they have their feedstocks so inexpensively in these areas. And the first thing to do is actually to look at whether there's products that you can make from algae that you can actually use locally to support other industries that are there. We have a big aquaculture industry, and that's an obvious area to deploy those products in.
Thank you, Douglas. You speak about circular economy like linked to green technology or to completely a process. Do you introduce the algae in the circular economy? It's to use the feedstock, but what you do after that with the algae that you produce on the feedstock? What type of use you preconize?
Well, if you look at it from a circular economy basis, in Scotland we have a number of large industries. Distillation's one of them, aquaculture's one. So if we can get the distillation industry to start supporting the aquaculture industry, while actually also solving a problem for the whisky industry, which is their co-products. At the moment, these are either disposed of into the sea or into cattle, often costing a lot of money. And we import feed into Scotland, quite a considerable amount of it as well, to feed into our salmon. So basically, if we can use the algae, not actually as the primary food for the salmon, but basically the nutritional supplements for them, so that we improve those feeds using the co-products that are coming from the distillery. Okay. So that's what we mean by that circular economy, getting industries to support each other.
Okay, thank you for this good example. Nathalie, could you pursue with your type of application in your site?
We have a similar approach than Xanthella at Innofib and also with the University of Quebec in Trois-Rivières. We have, in fact, two approaches. One is about multi-sectorial, and the other is about co-location and finding local use for co-products. First of all, Innofib strongly believe that there are a lot of actual technology that could be adapted to algae biomass production and processing. By example, many pulp and paper equipments can be used for the harvesting, dewatering, and even for algae cell rupture. Pulp and paper specialists have specific knowledge and experience on removing small particles and dewatering biomass. So by using their knowledge, we can decrease the cost of the algae biomass processing. Also, from a rural economics point of view, using pulp and paper equipments for algae processing can revitalize pulp and paper plants in a region and maintain jobs. So we can even think about having a microalgae producer around pulp and paper plants, not only to benefit from its equipment, but also to benefit from their waste energy and their waste nutrient as wastewater, sludge, or gaseous effluent, to decrease the overall cost of the microalgae production. In fact, we strongly believe that producing and processing microalgae with an industrial plant is very important for process economics. Many steps are involved in the algae production and processing, and that require a lot of energy, and we need waste energy to reduce its cost. By co-locating, we can even produce microalgae in winter climate in Canada. We have demonstrated in our microalgae production research project with a smelter of Rio Tinto Alcan in Quebec. Our data reveal that we were able to maintain a minimum of 20 degrees Celsius in our culture medium all over the year to produce a total of 10,000 dry tons of algae biomass in co-location with the smelter. About the nutrient waste, we all know that nutrients volume and availability is a critical issue in algae production process. Having cheap source of carbon, nutrient, phosphorus, and even other nutrients such as iron are required to have a profitable process. So by co-locating with an industrial plant, This gives us access to a lot of low-cost or even no-cost nutrients, and also, in some cases, at a lot of carbon dioxide. And I would like to add to that algae production in an area is very good to improve or relaunch regional economics. Algae production can increase synergy in a locality and create unusual one. By example, by bringing an algae producer on an industrial park, the algae producer have access to a different kind of wastewater that contain nutrients, and you can think also about co-products for some local businesses. This is what we are doing at Victoriaville City with the Professor Simon Barnabé of the University of Quebec in Trois-Rivières. So thinking multi-sectorial and locally and being in co-location is for us the best strategy to be successful on microalgae production.
Thank you, Nathalie. To continue in this type of discussion, so one aspect we have to speak when you are producing microalgae is how to obtain the components of the algae to try to obtain the highest value possible out of the components. So, Kelvin, what is your strategy about that in your organization?
Okay, and as for extracting value from the microalgae, and literally in this case we're talking extraction of the cell contents from microalgae itself. Our concept beyond, microalgae production is extremely important, being able to do it in a circular way. Getting the microalgae from carbon capture or from water purification and so on is really one way to keep the costs down, because the microalgae becomes a byproduct of the process of which those are doing. What we are trying to do is for those kinds of organizations, and actually any organization, since we're agnostic to the type of microalgae, we are validating and developing a technology for being able to get as much of the cell contents out of microalgae as possible. Not just the lipids, not just the sugars, but the proteins also. So you get all cell contents and the technology has been proven, at least up until the 1 gallon scale, is that they can get 90+% of the lipids, of the carbohydrates, and of the proteins that started in the microalgae. That is one way of trying to get as much value as possible. We're not trying to go just after the lipids, your biofuels or biodiesels. Unfortunately, those are the things you get very little price from when you try to sell that in the commercial markets. Your value actually comes from the carbohydrates and even more so from the proteins. But most technologies today for extracting your cell contents from microalgae, especially high pressure liquefaction and high temperature liquefaction, they actually denature the proteins, denature the sugars, and they're no longer viable when you're done those technologies. This technology does not denature the sugars and does not denature the proteins, so they're available to you. It's a way to actually get more value from the microalgae and the cell contents, and hopefully you can recover all your costs from the sugars and the proteins, and what you get from the lipids, selling off your biodiesels or converting it into lubricants and other things, will be the icing on the cake rather than the cake. And that's really the issue, I think, that most of the biodiesel industry is facing today, especially from microalgae. So what we're hoping to do is be able to turn the economics around and actually make the value actually from the other cell contents and not from the diesel itself.
Thank you very much. The last question, extraction high value of microalgae, ask for how the growth of company in this field a lot of challenge. You mentioned some example of strategy, improvement in innovation efforts based on your specific process part of microalgae production. It could be strain management, growth substrate, production, bioreactor design, energy consumption, components of extraction separation technology. Based on your backstory and work in this field, What are your near future specific challenge or demand or improvement you are looking for the next years?
Okay, there are 3 areas in which we've been seeing challenges for growing the technology. The first is microalgae supply. Right now, the available commercial microalgae supply is actually pretty small. Most of the facilities for microalgae are actually in the pilot scale, seeing they're going to go to the commercial scale in the next 2 to 3 to 4 years. But if you're trying to build something for bio-based chemicals and for bioplastics, you need hundreds of millions, if not billions of pounds of microalgae available a year. And right now, you're in maybe the tens of millions at the most. That needs to grow. The next is investment funding, especially for this kind of development, pre-validation. And that's just a problem that exists for all industries, all technologies, and so on. And I forget what the third is, sorry. We'll probably come back to it later.
So, Natalia, do you have some idea on that? Or
About challenge, one we consider at InnoFib is partnerships. Partnership is absolutely necessary. We cannot succeed alone. We have to cover all the chain of value with the best team. So thus, it may involve business, and university and technical college, and even local stakeholders. Also, there are many industries that are looking for algae biomass as a source of green products or energy, but they do not have the expertise to produce them. Then strategic alliance with the microalgae producing companies are required. And in fact, I think that the farm algae concept must be expanded to supply algae biomass to those industries looking for a green shift.
good, thank you.
Another challenge we consider at InnoFib is about finding cheap nutrients and securing the nutrients. Because microalgae do not grow only with light and CO2, it requires nutrients and also micronutrients. And most of the time, we require a lot of productivity, and high productivity is achieved on heterotrophy and mixotrophy condition. Then we need a lot of nutrients, and we are not the only who looking for cheap nutrients. All the fermentation industry are looking for that. So when we find a low cost or even no cost nutrient source, we must be sure to have it for 5, 10, even 20 years. So securing nutrients is a major issue in many areas, and microalgae is not spared from it. For our project with the Rio Tinto Alcan smelter, we didn't have enough nutrient in their wastewater, so we are looking for some other local cheap source of nutrient. And we find dairy byproduct, but we need 96 million liters per year to produce 10,000 tons of dry algae biomass, while we were able to secure only 25 million liters per year in the region. So then we had to use raw sugar and mineral salts, and our OPEX have drastically increased because of this.
Thank you very much. Douglas, to end.
Okay, just if we look at the recent history of microalgae and industry, it was driven very much by the interest in biofuels. And this has been both a curse and a blessing. It's a blessing because it meant an awful lot of money came into the area and it generated a lot of interest. The curse was that biofuels only really make sense at very, very large scale. And that makes it a huge financial risk. And the industry's not really delivered on this, and it's meant there's an awful lot of skepticism out there in investors relating to algae. You know, everything gets tarred with the same brush. If half the money that went into biofuels, in fact maybe a tenth, had gone into high-value products, we'd have had a lot more success stories early on, and it would have given investors a lot more confidence in the industry. It would have also given us the experience of doing things, small steps, You know, so rather than billion-liter refineries and things like that, we would produce products which would be very, very profitable, and it would teach us the lessons that we need to go forward. And more importantly, it would give us the engineers and the managers who really understand algae business. So I think that's a major thing that we've got to get over, but it's where we are. And now we need companies to be able to demonstrate that they can really make money from algae.
Mm-hmm. Yes, we have to make money with algae. So if I do a summary of what you tell this afternoon, you agree that we have to use available technology, and to use technology could be adapted to adapt microalgae production in circular economy using local feedstock, to use a wastewater remediation approach for microalgae production. So wastewater is not a wastewater, but a new feedstock. Improving regional economy, multi-sectorial approach, and to have bio-based chemicals, something like that, to feed the system. To use an approach like Kelvin referred to, biorefinery approach, to valorize all the components, to work with the local users and to adapt the scale to the local situation to be sure that we will have a profitability. All this type of subjects are linked to the thematics that we saw often in biomarine economy, means sustainable development, that we have also in Maritime Strategy of Quebec. Thank you very much.
Thank you. Thank you.